Like the other time we talk about the inflation and the decision theory of ways of handling risk. But what I can explain, what I got it clear is about the decision theory, where we are using the tree as a pictorial representation to make a decision where there are large variables in an organization. So with inflation, what I understand about the inflation is the increase in the price with time. So in that scenario, you also use the rate of inflation to advise the organization based on the decision or the risk involved in future.
Thank you. What about Rose? What did you get last time?
I also got the same on investment decisions and inflation, of which we say that inflation is associated with the general increase in prices of commodities, and also it increases the income and cash flows as well. And also I got a thing or two about the decision theory and about constructing the decision trees and also advising the management.
Thank you. I can see a good progress. Last time when we met here on Thursday, I was able to discuss about the decision trees, and it is one of the black spot. I'm expecting to be getting one question this semester from that area. And we say the decision trees are just pictorial representation. We said are just pictorial representations on which are normally used to make decisions where the variables involved are a bit large. And we remember we said to draw a decision tree, the decision which is going to be made normally depends on the sequence of events. We said that we start with the options available, and we said the options that we normally have under the decision, sometimes they are normally called decision nodes. And I said we normally have only two, whereby we are going to be using box, whereby the decision lies with us, right? Where we can be able to influence the outcome. But when we can't influence the outcome, that is when we talk about the state of nature node. And we said at that period, we normally use the circles. And I say that for instance, when you look on the predictions that we normally do in an organization in regards to preparation of the financial budgets, we normally have a challenge whereby we have to be putting ourselves in a scenario where we put other things to be, to put other elements to be constant. And from that aspect, we normally say, as the matters remain constant, we're expecting our organization to report a 50 billion profit. So when you look on the predictions and the assumptions that you have already used in the preparation of the budget, because they have to be in that they have to be indicated by the management accountants who are looking for the information which is necessary for decision making. We say within that period, when we can be able to influence the decision, let us use the box. We say when we cannot be able to influence the decisions or the outcome, then you are going to be using the circle. The circle. I'm aware that there are some of the questions which were raised by Joy in our WhatsApp group. And by the way, our WhatsApp group is not an area where we are supposed to be sharing only two things. Also, it is a platform to discuss our assignments, which I'm going to be giving out. I will be proud, by the way, to see those conversations going on as we move forward. Since before I finish the utility analysis, there's part of the risk techniques of handling risk. I'm aware that some of us will be able to forget on how we are going to be drawing a decision tree. Now, today, I just want us to look on a question, because I just want to start with the two questions for decision trees. I just want to do as many questions as I can for specific areas, so that when you are going to be doing revisions, you are not going to be coming up with some certain question like what I could see. My good friend Joy is having some questions in regards to these areas. So I'm expecting all of us to have the calculators and being very fast. They say for you to pass advanced financial management, you have to be checking on your speed. How am I going to be drawing up the line? By making sure that I have enough speed where I can be able to do the questions. Taking shortest time more than what is required by CASNEB, right? Now, Immaculate, CASNEB requires us to do one question with how many minutes? One question. CASNEB requires us to do one question with how many minutes? Immaculate? How many minutes am I supposed to be taking to do one question? Yes? Do you know how many minutes? Godfrey, how many minutes do CASNEB require me to do a question? One question.
A maximum of that 6.
A maximum of 36 minutes. So it means some of us, they don't know. Some of us, they don't know. We are required by CASNEB to do 36. We just need to take that 6 minutes to do only one question. And I think that is not the case as per what you have been doing in previous times, right? We normally take more than, I remember that one day, I don't know which paper I was doing, right? But I took more than 1 hour. Believe you me, if you are going to be taking more than 1 hour to do one question, automatically you have a good reason to repeat a paper. You have a good reason. If you take more than that, that is my analysis. What about yours? Can you be able to see my boards? Can you?
Yes.
Good. Now, I want to look on a good question here, which was tested the other day. Someone is going to be reading for us. Someone to read on our behalf. Let me see. Who is that person? Good. Thank you. Now, let's look on this question, which was tested on... can you see my question? April 2022, question 5B. April 2022, question number 5B. Someone to read for us, please. Someone?
Okay, let's read. Copper Limited is considering a project requiring an initial cash outlay of Kenya shillings 150 million. The project's life is 5 years, after which there would be no expected salvage value. The possible incremental after tax cash inflow and associated possibilities of occurrence are as follows. As you can see from that diagram.
Continue.
Peleka juu kidogo. I can't see it clearly. Okay. The company's required rate of return is for this investment is 12%. Required using a decision tree analysis, compute the expected net present value, ENPV of the project. Compute the standard deviation of the expected net present value in B above.
Thank you so much. You can see the examiner is giving you a challenge there where you're going to be drawing up a decision tree using the criteria which basically assist us to get the solutions of these questions. I can see the examiner is telling us that there is a project which requires us to incur a cost of 150 million. So we have been told that the project life of ours is 5 years, after which there will be no salvage value. There is no resale value. So we have been told the possible incremental after-tax cash flows, inflows, and associated probabilities are already given in the question. So already the decisions which we can be able to get and to get the net cash inflows is by making a decision on whether to invest or not to invest. So if I'm going to be investing, I have to be incurring a worth of 150 million shillings. Then in year one, I'm going to be having two possibilities. I might be I have a probability of getting 40 million, or I can have another probability of getting 45 million in year one, which is a lump sum. You can see it is a lump sum, right? The lump sum is because when you look on the cash flows of the two outcomes, they are not equal. They are not similar, right? But when you look on the conditional probabilities, not the conditional, but when you look on year 2 to year 5, the net cash flows for those respective years are going to be constant. For instance, we have been told we have a probability of 0.2 of getting 40 million within 2 to 5 years. We have a probability of 0.6 of getting 50 million within the similar years. We have 60. We have a probability of 0.2 of getting all the way under the probability of getting 0.2 of the 65 million. The biggest question is, the examiner is asking us to come up with a decision tree whereby we are going to be calculating the net present values. And I know that a new student might be asking, what is the net present value? You'll be able to say to tell you that it is the difference between the present value of the cash inflows minus the present value of the cash outflows. For instance, it does the difference between the total revenue minus the total cost. That is based on the aspect of the management. And we normally make the decisions based on the positivity or the outcome of the NPV. We say to make a decision for NPV, we have to be looking on the outcomes. If the NPV is positive, we say accept the project, right? If it is negative, we say reject the project. And then if it is equal, right, we say where the NPV is equal to 0, it is a point of indifference. We may or may not be able to accept the project. So what am I supposed to be doing under this question? Let me move quickly. So the examiner is requiring me to do this, right? This is what the examiner requires me to do. So we are being told here, I have an option to do. So I can do one thing here. Let me put it somewhere here. I have an option whether to invest or not to invest. So if I'm going to be investing, right, I'm going to be incurring 150 million, right? Then up I can say, don't invest, and I'm going to be getting nothing at the end of the day. So you can tell me the outcome here will be 0. The outcome there will be 0. Now, what comes when I invest, right? The outcome might not be necessarily known because we don't know the outcome. If you invest this one, then you have to be subjecting some probability and say, I may or may not get the outcome. And in this case, what am I going to be using? I'm going to be using the state of nature node. I'm not aware, I'm not sure whether I'm going to be generating this kind of cash flow. So in this case, we are being told in year 1, you can be able to get 40 million. The probability of getting 40 million, you are being given 0.5. The probability of getting 45 million, it is 0.5. We have an equal outcome there. You may get 40 or getting 45 million. Then we are being subjected to certain probabilities there. Right? Now, let us move on. Right? Let us move on. When I move on already, I have been given some branches here. If, for instance, in year one, I will be able to get 40 million, then there is a possibility of getting the other outcomes. And what are the outcomes? The examiner has already given you there, the other outcomes, and they are unknown. You are not sure. So use the state of nature node again, right? We might be getting that one. We might be getting this one, and then we get that one, right? This is between year 2 to year 5. The cash flow might be varying. There is a probability of 0.2. Not put there, right? Let me put it down here. There is a probability of 0.2 of getting how much? The examiner is telling me I can be able to generate a cash inflow of 40 million, right? There is another probability given there of 0.6 of generating 50 million. And then there is another probability of 0.2 of generating how much? We are being told you can be able to generate 60 million. Those are the outcomes given in that question. And also, I might also be able to get from the other side, given probabilities here, right? Given the probabilities and the respective outcomes. I have a probability of 0.1 of generating how much? 0.1. I can be able to generate 55 million. So here there is a probability of 0.1. When you look on the other outcome, I have a probability of 0.7 of generating a cash inflow of 60 million. And then I have another probability of 0.2 of generating 65 million. We say if you don't invest, then you're going to be getting nothing. You're going to be getting nothing. Ni kama tule mtu anasemanga, I wish I can be able to get certain wealth, certain amount. Lakini you don't want to take the risk. Person who is taking the risk, he has the probabilities of generating certain cash flows. Now, let us look on what am I supposed, now, based on the solution given in the question, what am I supposed to be doing here? The next thing that I'm supposed to be doing, just calculate your joint probabilities. Joint probabilities. How do I normally calculate the joint probabilities? Look on all the roads that you have used. Hadi nimepitia Thika Road, nikaingililia bypass, Osops, nikatokea Mombasa Road. So here, the outcome, the joint probability is 0.1. I have just taken 0.5 times 0.2, get it 0.1. Then also, if you use the other routes, 0.5 times 0.6, get it 0.3. Then the other one will be 0.5 times 0.2, get it 0.1. What about the other one? We are going to be looking on 0.5 times 0.1, get it 0.05. Then we have 0.5 times 0.7, we get 0.35. Then we have 0.5 times 0.2, get it 0.1. Get it 0.1. I know now we can be able to derive our joint probabilities, and we can be able to understand very well on how to calculate the joint probabilities. Let us look now, because the examiner is asking us to calculate the expected net present value. We say to get the expected net present value, just take the summation of NPV, you multiply by probabilities. Already we have our probabilities there, right? So what is the summation of the NPVs? So let us look on how we can be able to calculate the NPV. So in this case, to calculate our NPV, I'm going to be considering the cash flows which are existing here. For example, in year one, we said this type of cash flow is lump sum. And this type of a cash flow, right, it is annuity. Why am I saying it's annuity? Since I'm going to be generating 40 million within year 2 to year 5, I'm going to be getting 40 million. That is why it is normally called annuity. Every year getting from year 2 to year 5, 40 million. The similar cash flows. So how am I going to be getting the NPV? This is what you normally do. Take 40 million, you multiply by the present value interest factor. This is the one that is used under the discounting, right? You have the future value to determine the present value. We normally use the discounting. The formula for these, we say you take 1 plus r raised power negative n, or you use the table which I will be able to show you how to use it. Then plus the other cash flow which is generated within the respective number of years, here we are saying that we are going to be discounting with 12%, 5 years. Not 5 years, but year one, sorry. Year one. Then we add 40 million, right? Times the present value interest factor annuity, 12%. But this one should be done within year 2 to year 5. So inamaanisha hapa, we are not going to be considering year 1. So what are we going to be doing there? I'll be able to show you minus your initial outlay of 150 million. Or 150 million. You know now, what we are going to be generating up to this point, it is normally called the present value of the cash inflows. Then this is the present value of the cash outflows. What we are going to be getting at the end of the day here, the NPV, is what we are going to be getting there at the end of the day. How do I normally get this one? Because already we are talking about year 1, right? Use the formula. We say, let me take my calculator now, and I say, let me take 1.12. I raise power negative 1. Getting 0.8929 times 40. Let me limit it to millions, plus another 40 here. We multiply by. Now, how am I going to be doing this? Remember, under this bracket, year 1 is not needed. We just need a proportion or a probability for year 2 to year 5. For year 2 to year 5. What am I supposed to be doing? This is what you normally do. You normally say, let me take the present value interest factor annuity, 12%, 5 years, minus the present value interest factor annuity, 12%, 1 year. Because we will take year 1. So year 5, it may include year 1. Si nataka kutoka year 2 to year 5. What is the proportion? So mimi nikienda kwa table kama yenye mnapenda kuangalia sana hapa. Kama hii imepeanwa kwa hii swali. Angalia kama hii. Kuna table hapa, right? Wajanipea, oh good. So ukiangalia hii table, ndio tunasema ni table ya lump sum. So ukiangalia how we got 0.8929, itaangalia the number of years hapa. Ukiangalia hapa tumepewa period. Then you run row wise to 12. When you look on the 12%, you are getting 0.8929, and you can see the one that we have gotten using the formula given, right, for lump sum. What about for 5 years now? When I go to the other table for annuity, and you can see they are saying it is a present value interest factor for annuity, right, discounted, and you can see we are discussing about period number 1, year 1, and then we look on 12%. It will not change. It will be the same for like the one that we have checked there on the side of lump sum. What about when you look on year 5? Year 5 is here, right? On your left-hand side. Then when you run your row, you can see we are getting 3.6048. 3.6048, right? So that is what you normally do. When I go back to my board now, so ukiona mwalimu akisema wacha atumie formula. The formula for these, I can just take 1 minus 1 plus r raised to negative n divided by r. That is the formula that we say for annuity. So in this case, nikitaka kupata ile yenye nimeweka hapa yenye nimetoa kwa table, I just say 1.12. I raised to negative 5, right? 1 minus answer, then I divide by 0.12. You're going to be getting 3.6048. Now, 3.6048 minus 0.8929, we are getting, right? We are getting 2.7119. And that is the figure that you're going to be feeding here. You multiply with it here, 2.7119. Then we subtract our initial outlay, which is 150. So what is our NPV? So I just need to put this data of mine in my calculator. I say 40 times 0.8929 plus 40 times 2.7119 minus 150. And we're going to be getting negative 5.808. Good. 808. That is the first one. Then the second one will be, let me put the second one now. Nothing else will be changing. What will be changing is the cash flows. So the second one will be 40/50. So it will be 40 times, these ones are not going to be changing, right? The discount factors, 0.8929 plus, now this changes to 50. So this one will be 50 times 2.7119 minus 150. How much is this? 40 times 0.8929. 8929 plus 50 times 2.7119 minus 150. We are getting 21, right? We are getting 21.311. Good. Let us look on the other rods. The other rod will be 40 and 60. So I just repeat it. 40 times 0.8929 plus 60 now times 2.7119 minus 150. How much am I getting here? 40 times 0.8929 times, plus 60 times 2.7119 minus 150. And I'm getting 48.43. Let us go to the other rod now. We are discussing about now the side of 45. Just say, let's take 45 times 0.8929. Since the discount factors are not changing, then we take the first rod on the other side of the outcome. 55 times 2.7119 minus 150. So it means if I can just be able to change from my calculator, I just need to be putting 55 there, and I'm getting 39.34. Let me use 2 decimal places. Then let us use the other rod. We say 45, 0.8929 plus. Now we come to 60 million. Right, the 60. Then we multiply by 2.7119 minus 150. So how much it is? So I just changed my 55 now to 60. Getting 52.89. Then the last one will be 45 times 0.8929 plus, right, 65 times 2.7119 minus 150. So let us go to 65, getting 66.45. 66.45. Nani ajui venye tumepata hizi NPV zetu? Nani ajui venye tumepata our NPVs? Nani ajui venye tumepata NPVs? Good. If you all understand, right? Let us get the expected. And we have said, to get the expected, get the summation of NPV, multiplied by the probabilities. You have already calculated your joint probabilities here. So just come and you say, let me take my probabilities. The first one will be times 0.1 times 0.3 times 0.1 times 0.05 times 0.35 times how much here? Times 0.1. So let us get the expected NPV, right? The expected NPV. So the first one should be negative 0.581, right? The second one will be 21.31 times 0.3. I'm just using the 2 decimal places, sorry. So in this case, it is 6.39. 6.39. The other one will be 4.84. The other one will be 39.34 times 0.05, getting 1.97. Then the other one will be 52.89. You multiply by 0.35, getting 18.51. Then the last one will be 6.65. So what is the total here? What is the total there? What is the total? So let me do my summations. It will be 6.65 plus 18.51 plus 1.97 plus 4.84 plus 6.39 minus 0.58. Let me use 2 decimal places there. Getting that 7.78. That's 7.78. That's 7.78. Hakuna mtu ananiambia juu tumefika hapo aje. That is our expected NPV. Expected NPV. Now, let's shift our gears. The requirement part 2 already have 4 marks. The requirement part 2, this examiner is asking us to calculate the standard deviation. Who can remind us the formula for standard deviation? The formula for standard deviation? Joy? How do we normally get our standard deviation? Under advanced financial management? We normally take the root of?
The root of summation of NPV minus the expected squared, then we multiply the probability.
Thank you so much. So we normally take the summation of NPV minus expected NPV squared, you multiply by the probability. You multiply by the probability there, right? So in this case, let us look on the NPVs, and you can see you have all your NPVs here. So the first one will be negative 5.808, or we say 2 decimal places, right? So let me use negative 5.81, 21.31, right? You have 48.43. We also have 39.34. We have 52.89. Then the last one will be 66.45. We are subtracting what? Our expected NPV. Tumepata hapa. That's 7.78. That's 7.78. That's 7.78. That's 7.78. 37.78. 37.78. We said squared multiplied by our probability here, which is 0.1. Now squared here, multiplied by the probability of 0.35. Square here, then you multiply by 0.05. Square here, right? And then you multiply by our probability of 0.1. And then we square this one. And then we multiply by which probability? 0.3. Then the last one, we square the first one, and then we multiply by the probability of 0.1. Let us look on the outcomes. Now let's start with the first one, negative 5.81 minus 37.78 squared. Then I multiply by 0.1, getting 190. I'm getting here 190. The second one will be 21.31 minus 37.78, right, squared. Then I multiply by which probability? 0.3, getting 81.38. The next one will be 48.43 minus 37.78 squared. Then you multiply by 0.1, getting 11.34. Right? 39.34 minus 37.78 squared. Then we multiply by 0.05, getting 0.12. Then the other one will be 52.89 minus 37.78 squared times 0.35. 79.91. Then the last one will be 66.45 minus 37.78 squared. Then we multiply by 0.1, getting 82.20. So what is our total here? Right, the total will be plus 79.91 plus 0.12 plus 11.34 plus 81.38 plus 190. We are getting 444.95. So what is our standard deviation? We just need to say the root of 444.95. I just put this in my calculator, the root of my answer, and I'm going to be getting 21.09. That is my standard deviation. Someone to remind me what we said about making the decision using the standard deviation, and I will start with Rose. If the examiner was telling me to comment on my answer, ningemwambia nini? Rose? Rose? Rose, are you Leo? Eric? I remember the last time we said the higher the standard deviation, the higher the risk, right? So we are going, for instance, if we were to compare two projects, you could look on the one with the lowest standard deviation. I just want to look on another question before I shift my gears out of this, right? To do simulation. I just want to do simulation today. So let me look on another question which they tested on May 2018, question number 1C. Question 1C. Eric, read for us, please.
Hello.
Yes, move on.
Oh, okay. That's the Tabi. Tabi Limited has a potential investment opportunity for which the initial cash outlay and future cash flows are uncertain. The analysis carried out provided the following probability estimates. We have the probability estimates and the cash outlay at a probability of 0.40 and an amount of 250,000. We have and then the annual cash flows probability of 0.20 and the amount is 45,000. 0.25 probability amount 280,000 and 0.40 50,000. 0.25 300,000 and 0.40 60,000. 0.10 305,000. And then the additional information, you have the cost of capital is 10%. The life of the project is expected to be 10 years, and the salvage value is 0. We are required to construct a decision tree for the investment to show payoffs, probabilities, and NPVs for each alternative.
Very good. You can see that another examiner is trying to give us a question whereby they are giving you the cash outlay. You have the decision to make whether you can be able to spend 250 million or not. So those are your decisions. The probability are basically given there to make sure that if you have the probability of investing those kinds of money on certain projects, then the examiner is going to be giving you the annual cash inflows, right, for the respective initial outlays that you have already invested on certain projects. So how am I going to be doing this question? And let me go and give you the solution. So when I look on these questions, right? When I look on these questions, I can be able to say, I have a decision to invest those kind of money, right? I use a decision node. So we are given 4 options. You can see there's 4 options there, right? So the probabilities are basically given in the question. The examiner has already given me the probabilities of incurring this cash outlay. We are being given 0.4. Right, it should be, yes, 0.40, 0.25, the other one should be 0.25, and then the last one is 0.10. The other one is 0.10. So how much am I supposed to be incurring in this scenario? We are being told, let me incur an amount which I need on certain projects with respective probabilities. Why am I using this? Because it's my decision to invest this kind of money. The first one is 250. Let me reduce 2 millions to 80. Is it 250? Yes. It should be 250. 280. The other one should be 305 and 305. What will be the outcome? You are being given the annual outcomes there, providing up with the probabilities. The first one we are being given, 3, right? Let me put them there. So the outcomes will be, the probabilities for these outcomes will be given there, 0.2, 0.40, 0.40, right? Then the outcomes are already provided. It can be 45, 50, or 60. 45, 50, or 60 for all the amount that I'm going to be investing, by the way. It should be looking like that. So this is 0.20, 0.40, 0.40. So unaona hii kitu venye ni rahisi. 45, 50, 60. And also if I invest 300,000, the outcomes are given here: 0.20, 0.40, 0.40, 45, 50, and then we have 60. The last one will be the same. So here is 45, 50, and then we have 60 here. 0.20, 0.40, 0.40. Right? Now, the first thing that, and I told you, even if you don't know much about this, just calculate your joint probabilities. Let us look on the joint probabilities. The first one should be 0.08. This one should be 0.16, 0.16, 0.50, I think. The other one should be, let me take my calculator, although I know it should be 0. something one. 25, 0.25 times 0.4, translating to 0.1, 0.1, right? Then the other one would be it should be 0.50. Let me try and check. 0.25 times 0.2, yes, 0.05. The other one will be 0.4, coming to 0.1, 0.1, right? Then this one will be 0.02, 0.04, 0.04. Umefanya joint probabilities. So examiner anatuuliza vizuri, right? Examiner anauliza, construct a decision tree for the investment to show the payoffs, probabilities, and the net present values. So unajua, hizi cash flows nitazipata within year 1 to year 10. Those are the cash flows. This is annuity. Kiangalia vizuri. That is annuity. So itakuja tu hapa niseme, because already they are just one cash flow, right, for respective routes. So for example, the first one will be 45 times the present value interest factor annuity, 10%, 10 years, minus the initial outlay. How much was our initial outlay? When I look on the question, our initial outlay given in the question, for example, the first route, it is 250. So how much it is? So I can decide to use a formula for this. And I say 1.1 I raised to power negative 10. 1 minus answer, then we divide by 0.1. Utapata 6.1446 times 45. So it will be 45 times 6.1446 minus 250. So in this scenario, you can see, right? You can see here. Good. So you can see when you're calculating your NPVs here. So I can put mine there. And I say the first one is 26.51. What about the second one? The period is not going to be changing, by the way. What is going to be changing in the cash flow? So the second one, I just say 50 times my discount factor is not going to be changing. It will be 6.1446 minus 250. 57.23. The third one will be 60. And we are getting 118.68. When you go to the third one, or the second one now, this is the cost. Our cost changes and also our cash flow changes to 45 for the first one. Then the initial outlay changes to 280. So this one comes to negative 3.49. What about this one? Right, you can see the cash flow changes to 50. Then the other things remain constant. Then we are getting 27.23. Then when you look on the third one, the cash flow changes to 60. Then you are getting 88.68. Let us look on the other side where we are investing 300,000. Right? What will be the cash flow? The first one is 45, getting negative 23.49. The other one will be, after 45, we go to 50. Let's go to 50 now. So once you go to the 50, we are getting 7.23. The other one will be 60. Getting 68.68. Good. Let us go to 305 now. 305. Then our cash flow will be 45 for the first one. Negative 28.49. Then the other one will be 45, we go to 50. The discount factor does not change. I'm just changing the cash inflows for the respective and the initial place. So 50 by 305, getting how much? 2.23. Then the last one will be, the last one will be 60. Getting 63.68. 63.68. Anyone who can be able to tell me ajui hizo vitu zinatoka wapi? Anyone who can say, I don't know where those things are coming from? So kama tunajua, the examiner here requires us to get the expected NPV. Na ni rahisi sana, right? To get the expected NPV, hapa mwisho hapa. Expected NPV. Tulisema ni vitu rahisi. Multiply with your probabilities with your NPVs. Unafanya tu hivi kwa mtihani with no pressure. Hakuna pressure hata moja. You can see that. Now, let me start with the first one. 26.51 times 0.08. We are getting 2.12. The second one will be 57.23 times 0.16. We are getting 9.15 or 916. Let me put 16. Then the third one will be 118.68 times 0.16. Getting 18.99. The third one will be, or the other one will be negative 3.49 times 0.5. Getting negative 1.75. The other one will be 27.23 times 0.1. Oh, this simple 2.72. The other one is 8.87. The other one will be negative 23.49, right, times 0.05. Getting negative here, 1.17. The other one will be 7.23. We multiply by 0.1, getting 0.72. The other one will be 6.87. The other one will be negative 28.49. You multiply by 0.02, getting negative 0.57. 2.23, right, times 0.04. You can see you are getting 0.09. Then the last one will be 63.68. You multiply by 0.04. We are getting 2.55. Get your summation there. What is the total? Plus 0.09 plus, negative 0.57 plus 6.87 plus 0.72 minus 1.17 plus 8.87 plus 2.72 plus negative 1.7275, we add 18.99 plus 9.16 plus 2.12. Are you getting 48? 48.60. 48.60. 48.60. Someone has asked a question. Let me see. Okay. Am I clear now? I hope I'm not hanging right now. Is everything clear? Someone to talk to me? Is everything clear?
Yes.
Good, good, good. Thank you to alert me. I think I might be having a challenge of our network. Then the other thing that you can see an examiner is talking about there is saying, right, we have said, calculate the probabilities, the net present values for each alternative. That we have completed, 6 months. The expected NPV of the project, we have already gotten that. Then we have been told, if the NPV of the project is less than 5 million, Tabi Limited would be exposed to a hostile takeover. Compute the probability that Tabi Limited will avoid a hostile takeover. Assume a normal distribution and that the variance of the NPV is 1861.47, right? So what the examiner is trying to tell us, we are going to be using a normal distribution to get the solution of our case here. So ukitumia normal distribution tunasema tunatumia kaugali, right? Tumia kaugali namna hiyo. Examiner ni mjanja, amekupea nini? Amekupea variance to determine the standard deviation. So to get you remember during our Z-score, we used to say, take X minus over standard deviation. Ukikuja advanced level na kuambia, chukua the NPV minus the expected NPV. Then you divide by the standard deviation. You divide by the standard deviation. So in this case, this one which we call our mean, which we have already gotten, expected NPV of ours, we have gotten 48.60. So tumeambiwa, because you know our X here is in the point away from the mean. You know that one. But the examiner has already given us what? The point away from the mean. Ametupea nini? Examiner amesema, if the NPV of the project is less than 5 million. And you know, the point away from the mean iko side. So our NPV iko hapa, which is 5 now. Which is 5. Right? Tunaambiwa ikishuka hapa, the company will be exposed to hostile takeover. So unaambiwa, tafuta wakati haitakuwa exposed to hostile takeover, unakuja tu na rub. It is on this side. So in this case, tuna shade that side. That is the wanted side. But ile nguvu naweza tumia hii formula to get. Unaweza tu pata kutoka hapa from up to here. Hiyo ndio tunaweza pata tukitumia hii formula. What about the other side? We already know under the policies or the principles of probabilities, the area under the curve are always equal to 1. So tunajua up to this point where we have divided equally our curve, this area is 0.5. Na ingine ni 0.5. Lakini sisi attract the whole 0.5, tunataka hii proportion hii. Na tunaweza determine this part tukitumia this formula, right? So let us take our formula here by looking on the NPV. Our NPV is 5. The expected NPV is 48.60. You divide by our standard deviation. Examiner amekupea variance. Ametupea variance ya ngapi? Wacha tuangalie hapa. So our variance is 1861. So nakuja tunachukua the root of 1861.47. Itapata tu standard deviation. The root of 1861.47. Our standard deviation is 43.14. Hiyo ndio tunadivide nayo hapa. 43.14. Hii imepeanwa na examiner. Hiyo si yetu. Now in this case, let's look on the best way. So we take 5 minus 48.60. Then we divide by 43.14. Right? We are getting, I don't know whether we'll be able to, yes, we can. We are going to be getting 1.01. This one, you can see I'm not putting the negative because under the normal distributions, the negative are always ignored. So usikuja hapo niambie -1 ukatafuta kwa table, you will not get that. So in this case, we have 1.01. Get it from the table to get the probability from the table. You see, this is not a probability. So when you go to the normal distribution table, like the one that the examiner has given us, the normal distribution tables, let me see hii yetu ametupea hapa, right? Examiner ametupea yetu hapa mwisho. Hajatupea? right? Sasa yeye anataka tufanye namna gani? Hajatupea hapa. So in this case, waje tutafute the table for the normal distributions. So waje nitafute paper tofauti na hii, right? A paper where we can get these distribution tables given. So let me look for the same sitting, but I look for another paper called quantitative analysis. Let me see whether I can be able to get that normal distribution table there. Don't mind about the subjects. What we are interested in, it is a table, which I can see there. It should be good. So when you look on this normal distribution table, the examiner will always provide these one, the normal distribution tables, and you can see they are calling it the normal curves. You remember the solution for our question, we have gotten 1.01. So I have to be looking on the z-scores, and when you look on them, they are here. The z-scores provided that you have already been getting, that you have already gotten, sorry. So in this case, we are discussing about 1.0 z-score, 1.0, right? Then we go row-wise to 1.01. You are getting a probability of 0.34, right? 0.3438. I know kila mtu ameona how you can be able to check it from the normal distribution tables. 1.0, then you go to 1. You go to 1. You're going to be getting 0.3438. Now, after I got that, what am I supposed to be doing now? Let us go to the board and we see what are we supposed to be doing. Let me see what I can do. So after I get these, I just tell the examiner, that is just the probability of this area. That for that is. So to avoid exposing this company to hostile takeover, the probability should be the combination of what I've gotten and the other half. So it will be 0.3438 plus 0.5, getting 0.8438. This is the probability. This is the probability. Any question up to that point? Any question? Joy, are you okay? Joy, are you okay?
Yes, I'm okay.
Sorry?
Yes,
I'm not getting you.
I'm okay.
Very good. Immaculate, are you good? Immaculate? Okay. Who else? Who am I? Who am I remembering? Rose, are you okay?
Yes, I'm okay.
Very good. I can see Eric is okay. And also Godfrey might be okay. Might be. So I just want to look on the second technique of handling risk. The second technique of handling risk, right? We say number one is the division theory. We have done with it. But I will be able to give you an assignment which should be done by each and every one of you. So what will be the assignment for that case? The assignment for the decision tree should be September. Let me write up here. Assignments. We should be September 2021 question, because already I know right now you have the knowledge. Question 3B. Question 3B. To be able to do this question, repeat our videos, look on what we are supposed to be gathering, that the knowledge that we are supposed to be gathering from the video that we have done, then come and do September 2021. Number two, we normally discuss about simulation analysis. Simulation analysis. Simulation analysis, it is something that we have already done in the past. But what is to simulate? To simulate is to imitate. to imitate the reality. Is that how we normally write imitation? I think it should be like that. So to simulate it is to imitate the reality. Now, in this case, is it written like this? To imitate. I don't know, but my sub is so to simulate is to imitate the reality. And we are saying simulation is a technique used to describe the process, right? Simulation. Right? Simulation is a technique used to describe, is a technique which is used to describe the process, by developing, right? We normally develop what? We normally develop a model of that process, developing a model of that process. We develop a model of that process and conducting a series of trial and error, and conducting a series of trial and error experiments. Trial and error experiments. So in this case, we are saying the main reason is to predict the behavior of that process, right? The main reason is to predict the behavior of that process, right? Through time, normally with aid of computer program. With aid of computer programs. So sometimes we normally ask, how do we normally simulate? Because already we are saying to simulate is just to predict some few things here. We're going to be conducting a trial and error experiments, right? And we are saying the main reason is to predict the behavior of the process within a period of time. And we normally use the computer programs. So how do we normally simulate? And we can say we normally simulate by use of Monte Carlo mode of simulation, right? We normally use Monte Carlo simulation. So what is a Monte Carlo simulation? This is something that we did in the past. We say this is a way of allocating random numbers. It is a way of allocating random numbers. So already examiner is going to be giving me the random number to simulate, right? And how do I normally do that? The random numbers to variables given, because already we have the variables given. To variables given. So let us continue and say it is used when the elements exhibit the chances of occurrence, in their behavior. Tutaangalia venye tutatumia hizi vitu tukifanya illustration. How am I supposed to be using them? So let us look on the basic steps followed. Basic steps. Number one, right? What is the basic step number one? Identify the random number. Identify the random number which is uncertain. Number two, Attach the probabilities to events. Attach the probabilities to the events. Attach the probability to the events of the random variables. Of the random variables. Number three, we are saying, cumulate the probabilities. Cumulate the probabilities. Number four, we say, right, develop the random number ranges. Develop the random number ranges. Number five, right? Number five, prepare simulation worksheet. Prepare simulation worksheets. Prepare simulation worksheets. Prepare simulation worksheets. These are the things that we are supposed to be doing, by the way, when we are simulating. But ndio tuepukane na hii theory mingi, let me show you how to do this kind of question. What am I supposed to be doing? Let me look on a question which they tested here. That is a simple question tested here. So let me check on it for simulation. Not one, but we shall do two. So we are looking on the same year, but we are looking for a November period. So advanced financial management is here. And I said, if you need to pass this paper, this is easy, right? Because already it borrows a lot of information from respective units we have done before. Question 2B. Rose, can you read for us, please? Rose?
Galanema Limited is considering to introduce new cheap plastic rollers into the market. This will involve investing in a new plant at a cost of 280 million shillings. The plant is expected to have a useful life of 5 years, at the end of which salvage value will be nil. The firm's policy is to depreciate all of its fixed assets on a straight-line basis. Due to market uncertainties, the unit selling price, unit variable cost, and annual sales volume of the new plastic rollers have been estimated stochastically as follows. Could you kindly scroll down? We have the unit selling price, the values and the probabilities. For 35 shillings, we have 0.30 as the probability. For 30 shillings, we have 0.40 as the probability. For 50 shillings, we have 0.30 as the probability. We have the unit variable cost, the value and the probabilities. For 15 shillings, we have 0.20 as the probability. 10 shillings, 0.50 as the probability. For 25 shillings, we have 0.30 as the probability. We have the annual sales volume, the value, and the probabilities. The values are in million shillings. We have 4 million, we have 0.10 as the probability. 7 million as 0.60 as the probability. 9 million, 0.30 as the probability. In the additional information, 1, the firm expects to incur fixed operating costs, excluding depreciation, of shillings 30 million in each year. Second additional information, the company's cost of capital is 17%. Third additional information, the corporate tax rate is 30%. Required, 1, the expected net present value of the new product. 2, simulate the net present values using the following random numbers. We have the random numbers there, and compute the expected net present value of the project.
Thank you so much. I just want to start by looking on the requirement part 1, where the examiner is asking us to calculate the NPV of the project. So the NPV of the project, we have to be looking on the initial outlay. We say we normally follow 3 steps. Number 1, the initial outlay. Now, when I look on the information provided, I've been told Galanema Limited is considering to introduce new cheap plastic rulers into the market. And this will involve investing in a new plant at a cost of 280 million. So we can see in this question, the initial outlay will be the cost of the rulers or the cost of the plant. Because already we don't have any other incidental cost, and there is no any other theories provided in the question in regards to the disposal of an old machine and so on. Now, when you look on this aspect of the calculation of the NPV, I can see that I have to be using the same concept which I was able to learn on my first class under this topic. So in this scenario, I say to calculate my NPV, the step number one, I have to be looking on the initial outlay. Our initial outlay is equivalent to 280 million. That is true. Nothing else we are expecting there, right? There is no any additional cost incurred based on the installation and so on. Number two, we talked about the annual net cash flows. The annual net cash flows. And you can see the cash flows which are going to be generated by this based on this project we are doing. We are being told that the plant is expected to have a use of 5 years, the end of which the salvage value will be named. So the farm policy is to depreciate all the fixed assets on the straight line basis. But due to the market demands, and you can see uncertainties which are existing there, we are being provided with this kind of information based on the annual sales volume provided by this examiner. So what am I supposed to be doing? I'm always, and I will be able to check on these, that the annual contributions are not going to be changing, by the way, for the next 5 years. So this one might be, right? I think you are seeing my board. This should be the period I should be using annuity, 1 to 5 years. 1 to 5 years. So I'm looking on starting my question from the expected contribution. So mtu mwingine ataniuliza how mwalimu, nakwambia very simple. Already the examiner amekupea the unit selling prices with the probabilities. So what am I supposed to be doing? So I say, let me calculate the expected selling prices. I say, I just need to be taking my unit selling price and multiply by the probabilities. The first one is 35. I multiply by 0.3 plus 30 times, it should be 30 years, 0.4, right? 0.40 plus 50 times, naona hapa ni ngapi imebaki? 0.30. So how much it is in Kenya shillings? How much is that in Kenya shillings? And in this case, I say 35 times 0.3 plus 30 times 0.4, 30 times 0.4 plus 50 times 0.3, getting that 7.5. That's 7.5. Let me look on the expected variable costs, and I'm going to be doing the same, right? The expected variable costs. Now, in this case, the variable cost of mine will be 15 times 0.20 plus, right? We have 10 times 0.50. Then the last one will be 25 times 0.3. And you ask yourself, how much is my variable cost? It will be 15 times 0.20 plus 10 times 0.5 plus 25 times 0.3, getting 15.5. What is my contribution at the end of the day here per unit? Contribution margin per unit. So the contribution margin will be that 7.5 minus my answer, getting 22, right? Let's look on this expected sales volumes. Expected sales volume. You do the same, right? We take the probabilities, we take the annual sales volume for 4 times 0.1 plus, right? 7 times 0.6 plus, the other one would be 9 times 0.3. So hapa najiuliza, how much am I getting? 4 times 0.1 plus 7 times 0.6 plus 9 times 0.3, getting 7.3. So what is my total contribution here? I just need to take 22 times 7.3, which are units now. So 22 times my answer, I'm getting 160.6. 160.6. Next, now we have to be looking on lessing the fixed cost. Remember, we have started the question from the expected contribution, less fixed costs. Fixed cost provided in the additional information, and we are being told the firms expect to incur fixed operating costs excluding depreciation of 30 million. So here I subtract 30. I exclude that one. And what am I supposed to be getting here? I'm going to be getting only before depreciation and tax of 130.6. 130.6. Now after this, pay Kaisari yake, less tax at the rate of 30%. Right? Now 130.6 times 0.3, we are getting 39.18. 39.18, right? So in this case, how much are we getting after taxes? 130 minus answer, we're getting 90.82, right? That is after taxes. Then after that, we normally, because we said we have to be taking the easy routes, we normally add depreciation, tax sheets. Hii tulisema tunapatanga aje? We say take the cost minus the scrap, divide by the number of years. Then this one multiplied by tax rates. So in our case here, the cost of our project is 280 minus 0 divided by 5 years, right? And then the tax rate provided, sometimes it might vary, which is 30%. It might vary or not. So in this case, it will be 280 divided by 5, then we multiply by 0.3, getting 16.8. So what is our annual net cash flows? Annual net cash flows. Ukitumia ile manjia refu, hii ndio anzo utapata. Utapata 106 or 107, it should be 107.62. 107. Is it 107? Let me check. 130.6 minus 39.18. 91. This should be 91.42. Sorry, 91.42. Then plus 16.8. 16.8, getting 108.22. 108.22. That is my annual net cash flows. Najua na mmoja nifanye the third one. But examiner alituambia hakuna terminal cash flows. Examiner alituambia vizuri. No terminal cash flows because hakuna scrap value. So what am I supposed to be doing? I calculate my NPV now. So I take the number of years. The years will be 1 to 5 years. My cash flow, right? My cash flow will be 108.22. The discount factor of ours, we were being given certain rate there. The rate for our discount factor is 17% to determine my present value. So in this case, formula gani tunatumia hapa? 1 minus 1 plus R raised for a negative n divided by R because we are using annuities. Usiniambie sasa eti niende nifanye mwalimu aje nifanye ya 5 years ni minus ya 1. Hapana, hakuna ya 0. Hakuna ya, sorry, ya 5 ni minus ya 0, hakuna kitu kama hiyo. Ukiona 1 2, this is okay. This is okay. Now, it will be 1.17. We raise for a negative 5, 1 minus answer. Then we divide by 0.17. We are going to be getting 3.199. This should be 3. Then 3.11993 times 108.22. We are getting 346. 346.23. Then let's do it shortly. Our initial outlay is 280. Then I will be in a position to get the NPV. So minus 280, getting an NPV of 66.23. 66.23. So in this case, you can be able to tell them to invest on that project since our NPV is positive. Our NPV is positive. So kama ni advice angekuwa ameniuliza, that is the advice I could give the examiner. Let us go to number 2, the requirement part 2, unless there is a question. Number 2, the requirement part 2 now. The requirement 2, we are being told to simulate. So nikipewa data kama yenye naona hapa, na examiner nataka ni simulate. This is what I normally do. Sorry. This is what I normally do to simulate. So we normally start with the selling prices. The selling prices provided there, we have 35, we have 30, we have 50. We have the probabilities attached. So the probabilities attached, we have 0.3, 0.40, 0.30, right? We said calculate cumulative probabilities. Cumulative probabilities. So the cumulative probabilities of ours, tunachukua the first one, 0.30. This one plus 0.4 napata 0.70. This plus this one, you get 1.00. Let us go to range numbers. Hapa ndio tunasema, let us use the trial and error experiments. Trial and error experiments. So una add -1, plus -1. So in this case, we start, because we are coming up with ranges, it should be 00 to 29. It means I have subtracted 1 here. Then I add 1 here, becomes 30 to, this is 70 to 69. Then we go to 70 to 99. Remember, this is 1. So 0.99, you know that. So it should be 99. Let us go to the other one. We talk about variable cost. The variable cost provided in the question, examiner amekupea 15, 10, 25. Probabilities attached, tuko nazo. Already examiner amekupea 0.20, 0.50, and then we have 0.30. Calculate cumulative probabilities. 0.20 plus 0.50 getting 0.70 plus 0.3 getting 1. Range numbers look similar. So you start 00 to 19, usiniambie 20, right? You subtract 1 out of the probabilities here. Then in 19, unayad 1, inakuwa 20 to 69. Na maanisha nime subtract 1 kwa 70. Then we have 70 to 99. Let us go to sales volume. Sales volume, right? Sales volume. We have 479. 479, right? 479. Then I have probabilities 0.10, right? We have 0.60, right? And then we have 0.30. Cumulative 0.1, 0.701. 002, 09, because we have subtracted 1 here. 10, we have added 1 here to 69. Then we have 70 to 99. Nishamaliza hivyo, hata sitaki vitu mingi. Unaenda unasema, examiner amenipea random numbers there down. The random numbers provided zinanisaidia kusimulate. So hapa nasema, wacha ni come up na simulation worksheet. Simulation worksheet. Hii worksheet yangu ina contain nini? It is very simple. Hii worksheet yangu ina contain some few things. Let me check on them. So, I'm going to be having the number of trials. We can start with trials or runs. Let me write them here. You can have runs. Then we start with the selling price, random number. Variable cost, random number. Sales volume, random number. Sindio? Then what am I supposed to be getting there? I'm supposed to be getting earning before depreciation and tax. I will show you how to get it. Earning before depreciation and tax. Then after that, we are going to be getting our net cash flows. Net cash flows. Then at the end of the day, itapata NPV. So waje tuangalie. Hizi ni rahisi sana. Hizi si kama za management accounting. Hizi za kuallocate hizi random numbers. So nikiangalia pale chini, the examiner is talking about simulate the net present values using the random numbers provided. Amenishikanishia mbili. So naweza anza hapa 80, allocate them row wise. So the first one, the first word given, amenipea 80, 25, sorry. It should be the random number, 80, 25, right? And 60. Hiyo ndio batch ya kwanza amenipea. Number 1. Then the second one, examiner amenipea 63, 83, 51. 80, 25, 60, good. 63, 83, 51, right? 63, 83, 51, 05, 75, 05, 75, 30. Then the other one will be 1503, 53. 1503, 53. Then we have 60, 37. 85. The other one will be, you can first allocate 55, 35, 25. 35, 25. You know, this is struggle. Then the other one will be 24, 52, 39. 24, 52, 39. 24, 52, 39. The other one will be 36, 99, 48. 36, 99, 48. The other one will be 1602, 59. I think it should be looking like that. 1602, 52. It should be 52, not 59. Right? Then the last one will be, the last one will be 85, 70, 15. 85, 70, 15. 85, 70, 15. I think we are together up to that point. So mimi nikiangalia run zangu ni ngapi? 2, 3, 4, 5, 6, 7, 8, 9, and 10. They are 10 runs. So mimi nikitaka kumalizana selling price peke yake, nachukua random number zake nazirun column wise. So we can start with 80. Nakuja hapa naangalia 80 imelai wapi kwa range numbers. Napata ni kwa 50. Unakujanga hapo unaangalia the selling price. Unaweka hapa 50. The second one is 63. Nakuja naangalia imelai kwa the second range numbers. Nakuja huku mwisho natafuta. Napata ni 30. 2005. 05 imelai kwa the first range number. So it should be 35. Right? Then 15 lies where? Nikiangalia hapa 15 inalai bado kwa 35. 20 kwa 60. 60 lies on the second range number, which is 30. The other one will be 55. 55 lies on the second one, which is 30. The other one will be 24. 24, the first one, 35. This one is 30, right? 16 lies where? The first one, 35. Then we have 85, which lies on 50. Tuende ya variable costs. Tuanze na 25. Niangalia 25 ina lie on the. Nakuja hapa naangalia the second range number. Then nakuja hapa naona mwisho ni 10. So naika hapa 10. The second one will be 83. Nikiangalia 83 is on the last one. 25. 75 iko wapi? Nikiangalia hapa 75 iko kwa 25. 03. 03 iko kwa nani? The first one, which is 15. Right? Then we have 37. That 7 lies on the second range number, which is 10. We have 35. 35 lies on 10, correct? We have 52. 52 lies on 10. Then we have 99, which goes to 25. We have 02, which goes on the first range number, which is 15. Then we have 70, which lies on the third range number, which is 25 here. Just put here 25. Let us go now to sales volume. And when I look on the range numbers provided, the random numbers, we have 60. 60 lies on the second one, which is 7. 51, 7. 30, we go to 7. We have 53, the same range number. 85, 85 lies on 9. The last one, you can see, the last one. Then 25, also 7. 39, 7. 48, 7. 52, 7. 15, 7. You can see. How am I going to be getting the earning before depreciation and taxes? I'm going to be taking my contributions, which is, I'm going to be taking the selling price minus variable cost. I multiply by the sales volume minus fixed costs. Minus the fixed cost. The selling price minus the variable cost of each row times the sales volume minus the fixed cost. Our fixed cost we have been provided the question is 30. We go 30 million, right? So let me start with the first one here. We take 50 minus 10, which is 40. 40 times 7, which is 280. 280 minus 30, getting 250. Unaona us to make a calculator. When we look on the second one, we look on the selling price, which is 30, minus 25, getting 5, times 7, which you get 35, minus 30, which is your fixed, you get 5. The third one, you do the same. 35 minus 25 is 10, minus, not minus, but you multiply by 7. You get, we have said 10, 70. 70 minus 30, getting 40, right? The other one will be 35 minus 15, right? Getting 20, times 7, 140, minus 30, 110. Higher, 30 minus 10, 20. 20 minus 9, 180, minus 30, right? You get 150. Higher. 20 next. 30 minus 10, which is 20, 140, right? 150. 140, it should be 110, sorry. Higher. 20 next. 35 minus 10, it is 25, right? Times 7, minus 30, getting 145. Good. Then after that one, we are coming out to 30 minus 25. Get 5, 35, 5. Then the other one will be 35, 15, which you are getting 20. Times 7, 140, 110. Then the last one will be 50, right? Minus 25. 50 minus 25, getting 25 times 7. Minus 30, getting 145. I hope tuko pamoja mpaka hapo. Tuko pamoja mpaka that point. Now, let's look on the net cash flows. How do you normally get the net cash flows? Hii ni vitu ziko kwa kichwa sasa. Unasema, ndio nipate the net cash flows. Nachukua earning before depreciation and taxes. For example, the first one is 250. Unailes nini? Nailes tax, right? Our tax is 30%, right? After you less our tax, you add depreciation tax shields. Our depreciation tax shields, tulipata 16.8. It will not change. It will be 16.8. Ulichukua nini? 280, ukadivide by 5, then ukamultiply na 30%. Even if tulipata hii depreciation tax shield. So already unajua 280 ukadivide by 5, ukamultiply na 0.3, ukapata 16.8. So let me start with the first one, right? So I'm going to be saying, badala ya kutumia tax hapa, because this tax you less. So to get the net of tax, napaswa kutumia aje? What if I tell you, right? You multiply just here by 0.7. 1 minus 0.3. you get 0.7. So because staki calculations mingi na mimi ni mwerevu sana kwa mtihani, nasema mimi badala ya kutumia hii, I take 250 minus the tax which I have to be calculating all the way. Can I just take my earning before depreciation tax and then I multiply by 7 and then I add straight away the depreciation tax? Let's say 250 times 0.3 unapata 75. 250 minus answer unapata 175 plus 16.8 unapata na 191.8. What if I take 250 times 0.7 plus 16.8? I'm getting the same answer. So let me use the shortcut. This is 191.8. The second one will be 5 times 0.7 plus 16.8. Getting 20.3, right? The third one will be 40 times 0.7 plus 16.8. Getting 44.8. The third one will be 110 times 0.7 plus 16.8. Getting 93.8. Then the other one will be 150 times 0.7 plus 16.8. Getting 121.8. The other one will be 110, 93.8. Then we have 145 times 0.7 plus 16.8. Getting 118.3. The other one we have 5. 5 need to calculate up hakuna haja kurudia. 20.3. 110 nisha calculate, getting 93.8. The other one is 145 nisha calculate, nikapata 118.3. You can see how you should be beating the other students in an exam. Then we now look for the NPV. How am I going to be getting my NPV? Because I have the net cash flows. What is my discount factor? Nasema my discount factor, nilikuwa already nishapata. Because we know the discount factors of ours, it at the rate of 17%. 17%, right? And you know these are, right? You know very well, these are not annuities, but these are lump sums. Right? Let me check. These are annuities, sorry. So in this case, we know very well, if you do your math very proper, in a proper manner, we were able to get, even if we do it, it was 1 minus 1 plus r raised power negative n divided by r. So in this case, remember the cash flows that we are getting, they are annual cash flows for the period of 10 years. These are 10 runs, don't say they are 10 years, right? So it will be 1.17, you raise power negative 5, 1 minus answer, then we divide by 0.17, we are able to get 3.1993. So let me share, how am I supposed to be calculating the NPV for the first one? I'm supposed to be taking 191.8 times 3.1993 minus my initial outlay, which we said is 280. My initial outlay, which was 280. So hapa hakuna vitu mingi nafanya mimi. Nakuja tu hapa nasema, let me take my net cash flows. Na mimi ndakuwa tuna edit. For example, the first one I have said is 191.8 times my discount factor is not going to be changing. It will remain at 3.1993 minus 280, generating 333.63. 333.63. The second one will be 20. 20, right? It will be 20.3 times 3.1993 minus 280. Getting negative 215.05. The other one will be 44.8 times 3.1993 minus 280. Getting negative 136.67. Negative 136.67. The other one will be 93.8 times 3.1993. 1993, right? 1993 minus 280, getting 20.09. 20.09. The other one will be 121.8 times 3.1993 minus 280, getting 109.67. 93.8, we were able to get 20.09. The other one is 118. 118.3 times 3.1993 minus 280. We are getting 98.48. 20.3, we got negative 215.05. 93, 20.09. The last one is 98.48. What is the total here? What is our total for the NPV? What is the total for the NPV? It will be 98.48 plus 20.09 plus negative 215.05 plus 98.48 plus 20.09 plus 109.67, right? Plus 20.09 minus 136.67 minus 215.05. Then we add 333.63. We are getting around 133.76. 133.76. So ukishapata hiyo, wewe rudi tu kwa pale kwa paper, uangalie examiner yeye alikuwa anataka nini. Nikiangalia kwa karatasi, examiner was asking to compute the expected net present value of the project. So in this case, when I'm simulating and the examiner is asking the expected net present value, chukua the summation of NPV divided by the number of the entries. So in this case, we are saying, I just need to take 133.76. I divide by 10. I get 13.376. 13.376. 13.376. Any question? Any questions so far? If we don't have a question, I would like we stop at that point. Tomorrow we shall be able to do one question for simulation, and then I will be able to give you an assignment, and then shift our gears to sensitivity analysis. I know I have been a bit late today. To sensitivity analysis and also scenario analysis. That those ones we are going to be combining them and we do them tomorrow. So those ones, they don't have any problems. So let me stop at that point and I wish you good night. I'm also expecting to keep on revising for better understanding of what we are tackling. Let me stop at that point and I wish you good night. Let me stop and say bye-bye.
Good night.